Okay, this is Tyler Lentz, Chris Patton, Phase 2. This is what I have completed at the moment. I don't know if we're going to get the walking because I'm supposed to go to Santa Barbara tomorrow. So anyway, you have the crab bot looking thing here. Right now it's basically just going to do a coordinated stand-up, which is going to send signals to each one of the motors discreetly, telling it to make it stand up. The state machine is, as of yet, not quite ready to make it do coordinated walking and keep the center of mass, but I'm confident that if I had maybe one more day, I could probably have it walking up some stairs. It's just been kind of a battle keeping this thing, well, just doing this much work. Anyway, you can see there's 12 servo motors laid out here. There's a FPGA board here. That's plugged into the daughter card, and I redid that. That's let's see if I can get it under the light. There you go. So you can pull the card, this FPGA board out, and reuse it for other projects, and then plug it in. And there's the buffered I/O like in the other video. Only this is a tinier version and it's cleaner. There's a power tether that runs out the back. And once the board is programmed, you can unplug the USB, and there's a power tether off the daughter card to run the FPGA board discreetly. You have elbow, shoulder, rotation, and down, so you have quite a few degrees of freedom. It gives you options to walk at several different gait styles, where you could walk side to side, or you can walk by pivoting these and coming down and then dragging your leg back, or you can pull yourself forward like this and use the back to push. So you have a couple of different gait that you could do. You could even do side to side. So definitely a versatile platform that will allow me to do research in the future, as far as different modes of gait and also sensors and the like. So the code right now as it stands allows for individual position information to be fed to any of these servos, and will definitely act as the foundation of a robust state machine that'll probably be usable in many labs and in my own research. Anyway, without further ado, I'm going to attempt a coordinated stand-up, and then that'll have to do for phase 2. Now you can see that the legs have spread out and the weight is now being held up. And there's some space underneath. No tricks. Now you learn a lot about the order of the movements to make something like this stand up, because if I try to have it stand up by, just having the leg be straight out like this, you get way too much torque. And as it is, these motors are about the strongest ones I could get on my budget, and you can still hear them buzzing if you don't get the movement just quite right. You can give it a little lift, and that goes a long way. And if you curl the elbows in and do your lifts in 2 or 3 different stages, where you curl the arm in and then have it come down, and I could show that by killing the power. You could just as soon have the leg do this same stand up in a few different steps and pull and then lift itself like that, which requires a 3-part stance or so to stand up. But anyway, there goes the lights, and I think that's a good enough walkthrough to see that there's a fully functioning robot here that is probably gonna be doing some cool stuff here in the next couple months. Alright, thanks for the opportunity.